you the kind of work we do and who we are, so lots of faces and pictures, and really introduce you to our department and our mission for the campus, and then actually show a quick video, sort of like a animation video, 10 minutes or so, that talks about where the campus is going in terms of its energy supply future. So hopefully that'll be exciting, relevant, and an excellent launch point for us to have further conversation and Q&A as we walk towards Y2E2 for our building tour. So about 4 years ago, President Hennessy and Provost Etchemendy and their leadership committee really decided that sustainability needed a strong presence at Stanford, the campus, not just Stanford, the academic institution, and put a laser focus on all the initiatives that were already underway, but weren't necessarily being talked about in terms of sustainability. So the campus has had energy efficiency programs and metering in all its buildings, energy conservation, renewable energy projects and pilots, but we weren't quite calling them sustainability. So as sustainability exploded in the scene and became what it is today, as something that speaks to the triple bottom line of economy, environment, and equity, it became very important to the university to really focus on that subject and give it a name. On the academic side, started prior to this, a few years in advance, started the initiative on environment and sustainability, which really brought the focus towards all the interdisciplinary education, many of results of many you're probably directly experiencing in your classes and research topics. And then on the operations side, it got labeled Sustainable Stanford. That's the logo. And the Department of Sustainability and Energy Management came together under one administrative roof, where utilities, water services, civil infrastructure, parking and transportation, business services, all now report to the same executive director, my boss. And I run the programmatic side of sustainability outreach, education, coordination, research integration, as well as some of the other areas that you will soon see. SEM leads the initiative to advance sustainability in campus operations and directly responsible to lower the campus's footprint despite growth. So this is the mission, the Stanford operations team, as we look at the whole campus and its 8,000 plus acres. How many of you can guess how many buildings we have on campus? Think high. 15? No, much higher than that. 1,000. We have 1,000 buildings that are actually buildings, about 290 or a little over 300 that you can see from Google Earth or Maps and really call them buildings. They're over a certain square footage. But this is a huge campus, a huge municipality, a huge city. Campus has its own cogeneration plant, which some of you will tour tomorrow. So how does a city in itself, which really provides fully for the population that it supports, that the thinking and the operational decisions are often very different from how the academic research is leading and very similar to how a city is run. So we kind of have to deal with all the challenges, the resource adequacies or challenges for the future, and lower our footprint as much as possible to really set a good example for our campus population to show that we walk the walk, talk the walk the talk the talk, etc. So the key programs are those that we talked about, and the Office of Sustainability sort of weaves in and out of each of these programs. We provide support in all sorts of levels, and we're going to get to that. As I talk about what we do, there might be nuggets about what interests you, and that's what I'm hoping would stay with this presentation so we can have a conversation later, or you guys can contact us if any of this match your interest, your research interest for the university. So the Stanford ecosystem, pretty simple stuff. We use resources, but as a result, we also create environmental impact. And with the traditional definition of sustainability, meeting the needs of today without compromising the need for the future, that is very much what we hold true. And Stanford Operational Department, as well as all its partners, including our academic counterparts, such as Precourt and Woods, or PIE and Woods, we really believe in this notion, the common notion of sustainability and the definition, what it means. So our challenge is very much how to figure out minimizing the traffic impact. minimizing the air emissions impact and greenhouse gas emissions? How do we reduce solid waste and increase its diversion rate as much as possible so as little is going to the landfill as possible? And of course, the treatment of wastewater and others. And there are a lot of other elements that are not necessarily in the arrows, but again, we're looking at the full campus footprint. And in many cases, life cycle cost analysis is starting to come in and weigh in into some of those really long-term decisions and planning for the campus. So our mission is to help guide Stanford to sustainability in each of these areas: land use, transportation, green building, energy. Energy includes a lot of work on research and on IT or in IT space, which is of interest to a lot of students. Waste and, of course, student engagement in all this. And when we talk about students, it's the entire population of students with a various degree, varied degree of level, depth, research, and their duration and experience on campus. Because both the administration and us, we really strongly believe that the examples we create while we are here undoubtedly will leave an impact on your impression of Stanford and hopefully influence the decisions you make in your career and research in the future. And we want to be a test bed. We want to be a test case. We want to be your living and learning laboratory. So these are the people. Joseph Stagner, who's the executive director of the Business Services and Support. The red shirt's me. We have Director of Transportation, Bertie Hamilton, who directs the entire parking, transportation, and circulation on campus. Many of you may already know that we actually have one of the best transportation demand management programs in the country, if not the nation. We're platinum level bicycle-friendly campus. Our drive-alone rate has steadily reduced. And there have been a lot of incentives provided to the community to really move away from driving alone to alternative transportation on campus. Tom Zichterman, he runs our water infrastructure program in the civil services, so he makes the decisions on really where the water is coming from, where do they go, how are they supplied, the deep infrastructure stuff as far as water is concerned. Jerry Hamilton runs our facilities energy management group. This is where a lot of the folks who are interested in how buildings are operated on campus, they would probably contact him or contact me, and we would connect the dots. But his group is the most interesting group in terms of understanding how efficiency projects are done, retrofits, whole buildings retrofit program, looking at the controls and how buildings are really becoming a very, very important kind of focal point where energy efficiency really had to demonstrate itself. Robert Reed is our energy services leader. So if you guys are getting a campus Cardinal cogeneration tour, this is probably going to be, Robert might be leading the tour as a member of his staff. Dean Murray runs our thermal energy distribution. Those of you who study steam distribution and piping and the temperature, delta temperature, and where it should go, and the relationship with cogeneration, all of that, Dean's our expert. And then we have Rich Bidding within power systems. So range of experts, true practitioners on campus who are also a great resource to you if there is a research project that you're truly interested in and you want to look at Stanford as a case study. So our office, we do a lot of the strategic planning and long-range development, mixing with policy, where the nation, the world's going in terms of greenhouse gas emissions. So we finished the energy and climate plan, which you will see more on the video. We just finished the draft of the long-range transportation plan for the university looking into 2050. And the next in line and kind of being built right now is the sustainable water plan for the university. We do a lot of work on evaluations and reporting. Any guesses on what that means? This may not be of great interest to you, but it should be. What does it mean, evaluations and reporting on sustainability, and why does it matter to Stanford?
Our reputation?
Yes. So we get ranked, and we get ranked viciously, and Stanford's a competitor, and we like to win, right? So one of the reasons why we paid more and more attention to evaluations and reporting is not just to really understand how our metrics are performing against our own benchmarks and baselines and goals, but where does it stand compared to our peer institutions, whom we do compete with academically as well as in prestige and in setting standards for the rest of the country and the world. So Stanford ranks pretty well. If any of you follow the ranking, we do well in terms of how sustainable the campus is. 5th in the Sierra Club ranking, 2nd in Newsweek's recent ranking that came out. And these are pretty difficult ranks to accomplish because they really look at all aspects of sustainability, not just energy. Communication and education, this is where we're reaching out to campus and really providing a case study opportunity for students who are interested, for faculty who are interested to do joint collaboration, which happen all the time, and of course for staff. You know, so many people care about sustainability on campus, yet on a day-to-day, there may not be opportunities for people to realize what the other department is doing. So it's our job to connect the dots in a big way, a small way, whichever way that brings synergy and collaboration. Academic integration is where we actually teach a class in the winter quarter called Greening Buildings and Behavior. It's an introductory but highly interdisciplinary class where we get students from law school, business school, School of Engineering, where we do look at a building and how can we green its operations and look at energy and waste and water and other behavioral opportunities to shave off that kind of base load that always shows up, or the plug load that is always on top of the systems-related energy use in a building. So a lot of engineering students have found it extremely helpful despite the original notion like, oh, that's a behavioral course, maybe it doesn't relate to my work, but it actually is a cross-listed course between civil and environmental engineering as well as art systems. Behavioral programs on campus, and of course the participation campaigns where we're really learning, we're not there yet, but learning how to reach out to the entire student population, both graduate and undergraduate, on what are some of the ways students can participate, actively participate, beyond their intellectual exercise on campus, on becoming an active civil citizen of campus. So, you know, what would they do in order to actually directly reduce consumption and promote conservation on campus? Oh, and that's us. Jiffy is here. Hi, Jiffy. She's a grad student of Stanford, so there's a good example for you, hint, hint. And Heather Benz is one of our interns from the undergraduate population. Finance and administration, they do all the budget and management services to center business management. Those who are interested to learn how the business of utility runs, that's a good group to do internships with. And that's who they are. Parking and transportation. Anybody interested in looking at transportation from the perspective of energy, and energy from the perspective of transportation, and the nexus and the technology, our parking and transportation program is really, really strong in being ahead programmatically on what is going on in the nation. And there's a lot of room in terms of looking at technology, you know, the battery technology, or really bringing in what type of vehicles could be a good alternative to the kind of vehicles that are on campus today. So that kind of energy-related research are very valuable, and we're always looking for student input. And this is our drive alone rate, that through all these programmatic improvements as well as collaboration with the academic side, successfully have driven the drive alone rate on campus. That's a big group. That's a big group, and they've been, the PNT program got started about a good 8 years ago. The provost started this, and it was very important for the campus to really get its traffic under control. Utility services, water and energy. Our total utility bill is about $72 million. Does that surprise you? No? Yeah, so it's about $72 million, just so you know. But that means that's how big the opportunity is to shrink that pie, and that's how badly we need for it not to grow further. Water services, they do water conservation, systems engineering, management and planning, environmental quality, roads, bridges, dams, water systems operations, you name it. The campus really has a sample of each of the civil infrastructure you can think of anywhere. We have some form of it on campus because of the size. So it's a good test bed and study opportunity. Our entire campus map, and it kind of shows where we are getting water through groundwater wells versus domestic water wells. Again, water is of interest to many of you coming in from energy because of the energy-water nexus. We get water from various different systems. So those who study hydrology, they find it very interesting on how Stanford's water system, which is mostly gravitational, is set up, which is set up really well. Those are the water folks. So if you already work with any of them and you recognize, then you're already well connected. Facilities energy management. This is the group that works on building energy efficiency. They work on both how to improve the efficiency of existing buildings as well as how to convert some of those best practices and pass on to the new buildings that are coming on campus. So the new building standards on campus are pretty high. It's about 30% more energy efficient compared to ASHRAE code and 25% more water efficient compared to buildings of its type on campus. And those of you familiar with LEED, that's about LEED Gold equivalent. Looking at the new Science and Engineering Quad, which we will tour in a bit, as well as the new Graduate School of Business, you can really see that some of those practices are really being put in place and hopefully more in the future. So these are the group. We have Jerry Hamilton, Susan Kulakowski, Scott Gould. That's probably a name that most graduate students end up knowing about, and I bet some of you here know. He does a lot of the work on the renewable research. This is a great group to really hook up with. And Joyce Dickerson, who focuses on sustainable IT virtualization of servers, IT technology, energy efficiency, et cetera. And there's the whole controls team. I don't mean to create the impression that there is a group of people just waiting for work because it's a very small team compared to the hundreds of buildings of campus that support. But the important point here is that Stanford's one of those universities, rare universities, that actually pay attention enough to have specialized teams like that. And they are a resource to you if you are studying at that level. Early campus power. This is just a preamble to the cogen. No coal smoke. But 1889, there was the first powerhouse, and that's your original quad. I think Hoover Tower is being constructed or something. But that was the early source of power on campus, and today we have the cogeneration plant in place since 1886 or 85, I forget. But when most people were still on coal, Stanford moved to cogeneration around the same time as Berkeley and some of the other campuses adopted cogeneration in the Bay Area, but we are one of the early adopters of cogeneration. And now moving beyond cogeneration when a lot of the universities are just starting to get into cogeneration. So this has raised a lot of questions and controversy and an interesting thing for you to ponder maybe after you watch the video. Energy services team. Thermal energy distribution, again, just the whole system study and how the temperatures and the distributions are maintained on campus. The thermal team on campus, real people doing the real work on campus. One thing that will strike you about working with the operations staff is everybody in the team really love what they do, and they have a deep sense of commitment towards the campus, which can be very heartening and a practical experience for many of the graduate students to experience. The power systems team, they provide reliable, cost-effective system, and they have their own logo. This is the huge the electric service area for campus, and the map is very similar to sort of where we have. Our cogeneration is actually oversized. The excess power that the campus doesn't use go back to PG&E. They have a high-voltage shop, the folks who pay attention to everything that's going on. So with that, there is an initiative. The artist formerly known as the Energy and Climate Plan, which is now being called SESI, Central Energy Systems Improvement, up for the final round of Board of Trustees approval this October, and the main tool for the campus to reduce its greenhouse gas emissions. So keep your fingers crossed, and let's talk right after the video. Thanks for your attention.
Founded in 1885, Stanford University is located in the heart of Silicon Valley. The 8,000-acre campus enjoys a Mediterranean climate and is home to over 1,000 buildings. A large research campus of this size requires a substantial amount of energy for its operations, translating to annual greenhouse gas emissions of about 262,000 metric tons of carbon dioxide equivalent, and this is expected to grow as the university grows to support its academic mission. Since the 1980s, Stanford has employed best practices to minimize the cost and environmental impact of its operations. The campus has employed energy metering in all its buildings, used efficient natural gas-fired cogeneration for its energy supply, retrofitted buildings with efficient systems, implemented stringent building standards, invested in renewable power, conserved water, and reduced automobile commute emissions to 1990 levels. Now, Stanford accepts the challenge to go beyond these efforts and raise the bar in the use of innovative and renewable energy supplies to further reduce its environmental impact and cost. The Long-Range Energy and Climate Plan has involved and integrated many considerations, including a broad search for innovation from faculty, staff, and students, engineering and financial models, and peer reviews. The key components of this plan are high-efficiency standards for new buildings, continued efficiency improvements in existing buildings, and a cutting-edge energy supply system, which we feature in this presentation. Energy production from the Cardinal Cogeneration Plant is the largest source of Stanford's greenhouse gas emissions, and it uses 1/4 of the campus water. Given this, plus the age of the plant and the volatility of fossil fuel prices, changes to Stanford's energy supply became key to the Energy and Climate Plan. Upon review of its energy use, Stanford identified a significant simultaneous need for both heating and cooling in its buildings throughout the year. The campus discovered the opportunity to recover most of the heat normally discharged from the cooling system and use it to meet much of the campus heating loads. This not only saves energy and lowers operating costs, but also significantly reduces greenhouse gas emissions and water use. Hence, the plan proposes to incorporate heat recovery as a key feature in Stanford's long-term energy system. Let us watch an animation explaining how heat recovery can be a more efficient source of energy for Stanford. With cogeneration, natural gas is used to produce electricity and steam for building power and heat. Some of this electricity and steam is also used to make chilled water to cool the buildings. Electricity, steam, and chilled water from the cogeneration unit at the Central Energy Facility are transported across campus to buildings via underground cables and pipelines, and spent steam or condensate and chilled water are returned back to the Central Energy Facility for reprocessing. At this facility, waste heat from the buildings collected by the chilled water system is discharged into the atmosphere via evaporative cooling towers. About 90% of the university's energy is currently supplied by the cogeneration plant in this way. A close-up shows how the steam and chilled water systems currently work in buildings. First, we show the steam loop with the red lines. Steam from the Central Energy Facility enters the building and through heat exchangers produces both warm air for space conditioning and hot water for restrooms, kitchens, and laboratories. Afterwards, the steam changes into very hot water, known as condensate, and is returned to the Central Energy Facility to be reheated back into steam and then sent out to buildings again. Now, we show the chilled water loop with the blue lines, which can also be thought of as a process of collecting waste heat. Chilled water enters the building and through a different heat exchanger provides cold air to cool the building. After collecting waste heat, the chilled water is then piped back to the Central Energy Facility for recooling by discharging the waste heat into the atmosphere via evaporative cooling towers. This picture is also an example of the simultaneous demand for heating and cooling of campus buildings, creating the opportunity for heat recovery. In a typical large university building, different rooms require different temperatures, depending on what kind of equipment and activities are taking place. For example, unoccupied computer server rooms typically need cooler temperatures than office spaces, so the main air supply to the building must be cooler than the air supplied to rooms with occupants, which must then be warmed locally. This local warming, known as the reheat process, is accomplished by the building hot water hydronic system using heat provided by the campus steam loop. At Stanford, the real-time overlap of heat being collected from the campus by the chilled water loop and heat being delivered to the campus by the steam loop occurs 70% of the time. This significant overlap presents the opportunity for heat recovery, that is, using the waste heat collected by the chilled water system to supply the heat needed by the campus at the same time. In the new heat recovery design, the waste heat collected from buildings via the chilled water loop will be captured at the central energy facility for reuse. This will eliminate the use of conventional chillers to discharge waste heat out of cooling towers by 70%. Instead, heat recovery chillers will be used to move the waste heat collected from the chilled water loop to a new hot water loop. The new hot water loop will replace the current steam system for delivering heat to the campus, and it will be more efficient and safer than the current steam loop, greatly reducing the heat losses in the distribution system. Due to the substantial reuse of heat and the lower line losses, this new combined heat and cooling process is about 70% more efficient than the existing combined heat and power process provided by the current cogeneration plant. A great feature of the heat recovery design is the significant reduction in water use. Since 70% of the waste heat from the chilled water loop is reused instead of being discharged out the evaporative cooling towers, water use is reduced proportionally. At Stanford, about 1/4 of our total freshwater supply is currently used in the cooling process, and this can be mostly eliminated with heat recovery. Converting the campus to heat recovery and hot water distribution, along with other system improvements, will require a significant investment. While the heat recovery approach has a modestly higher upfront cost than a conventional approach, it will pay Stanford back the extra capital investment many times over in coming decades, while significantly improving the environmental sustainability of Stanford. The Stanford Energy and Climate Plan is a balanced approach of constructing high-performance buildings, improving efficiency in existing buildings, and a new energy supply system, which we featured in this presentation. Today, 90% of our greenhouse gas emissions come from the cogeneration plant, which uses 25% of the campus water supply. With the new heat recovery plant, the campus will utilize 70% of the waste heat previously expelled from the cooling towers, use 18% less water, and reduce greenhouse gas emissions well below 1990 levels by 2020. Just as Stanford's move to cogeneration 25 years ago represented a major shift in campus energy technology for the better, the heat recovery scheme represents a significant step forward to a more efficient and sustainable technology. The Energy and Climate Plan is yet another demonstration of Stanford's institutional commitment to sustainability and the legacy of adept business investment in research and action. For more information, visit us at sustainable.stanford.edu/climate_action. Thank you.